Is Google's new AlphaDev a game changer in the AI industry? Many experts say that AlphaDev, developed by Google's DeepMind, is making newer advancements in computer science. Let's explore in depth about AlphaDev. There may not be a more fundamental task in the field of computer science than to sort. Choose between a bubble, heap, or merge. Millions of beginners have used the techniques for rearranging data inside of computers as practice exercises, and experienced developers have been perfecting them for decades. Any programming language that has a sort method has reliable code. Avoid touching it, it already performs admirably. However, an AI system created by Google's DeepMind programmers last year outperformed greatly by a tiny but significant margin. The system, which DeepMind refers to as AlphaDev, was tasked with devising a novel method for sorting brief sequences of numbers in the well-known coding language C++. It entailed getting inside the machine and having the AI create new algorithms in assembly code. The instructions that link programming languages like C++ to hardware. When a C++ programmer instructs the computer to sort, the developer's instructions are translated into machine-readable code that instructs the processor and memory of the computer exactly what to do, including where to move the data and how to modify it. Bits and metal come together there. DeepMind has continued to make important advancements in computer science. A version of the company's AI for gaming, AlphaZero, was employed last year to uncover new ways to accelerate the calculation of a key mathematical formula that is at the core of many different types of code, breaking a 50-year-old record in the process. The identical ruse has now been used twice. The UK-based company recently rebranded Google DeepMind following a merger with its sister company's AI lab in April. Has found a way to sort items in a list up to 70% faster than the best available approach by using a new version of AlphaZero called AlphaDev. Additionally, it has discovered a way to 30% increase the speed of a cryptographic key algorithm. These algorithms are some of the most typical components of software. Small speedups can have a big impact, saving money and energy. Moore's Law is coming to an end, where chips are approaching their fundamental physical limits, claims Daniel Mankiewicz, a research scientist at Google DeepMind. We must develop fresh, creative approaches to computing optimization. Peter Sanders, who does research on the creation and application of effective algorithms at the Karl Reusch Institute of Technology in Germany, and who was not involved in the work, calls it an interesting new approach. He claims that one of the most often utilized subroutines in computing is sorting. Recently, DeepMind published their findings in Nature. However, millions of software developers already employ the strategies that AlphaDev uncovered. AlphaDev's sorting algorithms were accepted into C++, one of the most widely used programming languages, when DeepMind submitted them in January 2022. This was followed by 2 months of thorough independent review. This was the first modification to C++'s sorting algorithms in more than a decade, and the first time an algorithm found using artificial intelligence was used. Abseil, an open-source library of pre-written C++ algorithms that can be used by anyone developing in C++, now includes DeepMind's additional new algorithms. These encryption techniques generate hash numbers, which are unique identifiers for all types of data. According to DeepMind, the new algorithms are currently employed trillions of times every day. AlphaZero, the reinforcement learning model that DeepMind developed to excel at games like Go and chess, is the foundation around which AlphaDev is based. The company's innovation was to adopt the same strategy it did the previous year to accelerate matrix multiplications, to treat the challenge of discovering a faster algorithm as a game and then train its AI to win it. In the instance of AlphaDev, the game entails selecting and arranging computer instructions so that the resulting lines of code constitute an algorithm. If the algorithm is both accurate and quicker than others, AlphaDev prevails. Although it appears straightforward, AlphaDev needs to sift through an absurdly large amount of potential movements in order to play properly. Assembly is a programming language that can be used to provide detailed instructions for how to move numbers around on a computer chip, and DeepMind chose to utilize it for its work. Assembly is a rare kind of programming that is used to transform code written in languages like C++ before it is executed. The benefit of assembly is that it enables algorithms to be broken down into precise steps, which is a nice place to start if you're searching for efficiencies. Numerous slots on computer chips are used to store and process numbers. Basic instructions for manipulating the data in these slots are included in the assembly, such as move AB, which instructs a computer to shift the number in slot A to slot B, and CMP AB, which instructs a computer to determine whether the value in slot A is less than, equal to, or larger than the value in slot B. Lengthy chains of these instructions can carry out all of a computer's operations. However, people have been studying and improving short algorithms for decades. As a proof of concept, Mankiewicz and his colleagues began by sorting a list of 3 things using an algorithm. The most effective human-made implementation of this algorithm consists of 18 instructions. They didn't think they could make it better. Mankiewicz admits, "Honestly, we didn't expect to achieve anything better, but to our astonishment, we were able to accelerate." When we examined the software, we realized that AlphaDev had actually found something. At first, we assumed this was a mistake or a bug of some kind. 3 items were arranged in a list by AlphaDev in 17 instructions as opposed to 18. It was determined that several procedures may be omitted. Mankiewicz says, "When we looked at it later, we were like, wow, that really makes sense, but it takes someone knowledgeable about assembly language to find anything like this without AlphaDev." The best human algorithm for sorting a list of 4 things, which requires 28 instructions, was not superior to AlphaDev's version. However, it reduced the amount of instructions from 46 to 42, outperforming the best human version for 5 items. That is a tremendous acceleration. On a typical Intel Skylake CPU, the current C++ approach for sorting a list of 5 items took approximately 6.91 nanoseconds. 2.01 nanoseconds, or around 70% faster, was taken by AlphaDev. This is the rationale for Demis Hassabis founding DeepMind. 1 year after it caught biologists off guard, AlphaFold revolutionized research methodology and transformed DeepMind's direction. AlphaDev's discovery is compared by DeepMind to one of AlphaGo's bizarre but successful strategies in its 2016 Go match against Grandmaster Lee Sedol. This isn't the appropriate thing to do, all the experts concluded after examining this move. This is a bad move, Mankiewicz says. However, it turned out to be the perfect choice, and AlphaGo not only succeeded in winning the match, but also had a significant impact on the strategies adopted by top-level Go players. Even while Sanders is impressed, he does not believe the outcomes should be overstated. Everyone anticipates that soon, AIs will be able to create new, better algorithms, and I agree that machine learning approaches are changing programming, but we're still not there yet. One factor, according to Sanders, is that just a portion of the assembly instructions are used by AlphaDev. According to him, many sorting algorithms in use now employ instructions that AlphaDev did not test. This makes comparing AlphaDev to the most effective competing strategies more difficult. AlphaDev does indeed have certain limitations. Its longest algorithm, which sorted a list of up to 5 items, had 130 instructions. AlphaDev was selected among 297 different assembly instructions, many at each phase. Learning slowed down after 297 instructions and assembly games with more than 130 directions, according to Mankiewicz. This is due to the fact that even with 297 instructions or game moves, the number of conceivable algorithms AlphaDev might create is greater than the potential number of chess games and estimated number of atoms in the universe. The team intends to modify AlphaDev such that it uses C++ instructions rather than assembly for longer algorithms. AlphaDev might overlook certain shortcuts with less precise control, but the strategy would work for a wider variety of algorithms. Sanders also wants to see a more thorough comparison with the finest methods created by humans, particularly for longer algorithms. That is reportedly part of DeepMind's strategy. Mankiewicz hopes to get AlphaDev to build on human intuition rather than from scratch by combining it with the greatest human-developed techniques. After all, other speedups might be discovered. For a human to do this, it requires significant expertise and a huge amount of hours, maybe days, maybe weeks, to look through these programs and identify improvements, asserts Mankiewicz. Therefore, it hasn't been tried before. That's it! What do you think of Google AlphaDev? Let us know in the comments below. For more videos like this, subscribe to our channel.